My name is Agam Kalista Wibowo. I'm from SCST-TIGP Academia Sinica. I would like to deliver my final report in Advanced Physical Chemistry 1 entitled Solvent Polarity under Vibrational Strong Coupling or VSC, written by Ch. Piechko and his colleague. First of all, I would like to explain part of this section. First is introduction, second is methodology. Third is result and discussion, including key results. And the last is conclusion and impact of the study. First, what is vibrational strong coupling or VSC? VSC is the process by which molecular vibration hybridates with an optical cavity mode. It is an interactive mediated by vacuum fluctuation. VSC affects the selectivity and kinetics of chemical process, as you can see in this figure. And talking about quantum fluctuation have measurable consequences. They belong to the domain of physics, but can also impact chemical properties. And from the transient of omnipresent variation of the electromagnetic field in space, we can create the phenomena like spontaneous emission, the Casimir-Boulder force, Lamb shift, and the last is London dispersion force. The electromagnetic fluctuations are important for several things like understanding basic processes such as water autoprotolysis, the surface enhanced Raman effect, and the last is can be used to directly alter the chemical properties. And how to create a system enter the vibrational strong coupling VSC regime. If energy is transferred between the two faster than it dissipated, hybrid-like matter states are created when a molecule is placed inside an optical cavity, as you can see in this figure, that is resonant with a certain vibrational mode, resulting the creation of the two vibrational band, P plus and P minus, and dark state or DS, as you can see in this figure. You can see in this figure, there is an exchange in virtual photon exchange between the molecular vibration and cavity modes. The systematic diagram of the formation of the upper P plus and lower P minus polarization and the gradient dark state from resonant, vibrational, and optical transition. There are many chemical properties are altered by VSC. For example, reaction kinetics, chemo, stereo, selectivity, ionic conductivity, the rate of vibrational energy transfer, selective crystallization, and the last is self-assembly. There are several coupling-induced effects observed by several researchers, including direct coupling of the reactant vibration by Thomas, cooperative coupling, solvent vibration co-resonant with a vibrational band of the reactant is coupled by Latter and George, and the last is coupling of the solvent alone by Ann. And what is the requirement to accomplish VSC? If the Rabi splitting larger than the full width at half maximum of F or FWHM of the vibrational band and the cavity mode. The Rabi splitting is the energy splitting between the P plus and P minus state. And how to achieve VSC? There is two things that can be achieved by VSC. First, rising the solute concentration. Second is by coupling the solute directly to the solvent. And what factors that influence the solvation? First, the microscopic intermolecular interaction. The second is the macroscopic properties of the solvent, as you can see in figure 2. Figure 2, solvation can be seen in terms of a macroscopic effective medium and or as a consequence of microscopic interaction between the solute and the solvent molecule. And how microsolvation would be affected? If the strong coupling affects the solvent relative permittivity and or polarizability. And what is macroscopic observation or microsolvation? It is if under strong coupling, it is also possible to modify local interaction like hydrogen bonding or dispersion interaction. There are several studies has demonstrated that VSC will have an effect on solvation sensitive system, including self-assembly, and second is enzyme catalyzed reaction, and the third is proton transfer. And there is several problems mentioned in this paper. First problem is a precise comprehension of the underlying mechanism at work is still not clear. And the second is the effect of VSC on the polarity and other properties of the solvent have not been systematically studied. And therefore, the research objective of this paper is this paper study solvent properties under VSC by using RD or Richard dye, which is a solvent polarity probe. And they use this method because it is possible to distinguish minute variation in solvent properties and polarity due to the strong negative solvatochronism. And the polarity of several alcohol solvent at visible wavelength was measured by Richard dye, and it's also a strong solvatochromic response. They measured the polarity change using this equation, polarity parameter. And as you can see, H is Planck constant, C is the speed of light, N is Avogadro constant, and delta max is the absorption maximum of the polarity sensitive intermolecular change transfer or CT band. As you can see in this figure, it is well known that lambda max shift over the visible spectrum moving from the near IR region, non-polar solvent, to the UV region, polar solvent, such as in water. And when solvent polarity negative, solvatochronism increase, the gap increase as well, because it is the CT band cover the whole visible spectrum. They conducted 3 types of experiment in their study. First, on resonance cavity experiments, which is one of more optical modes are resonant with a vibrational band of the solvent at normal incidence to the cavity. Second, off resonance cavity experiment, which the cavity is detuned to prevent any coupling, serving as the first type of control experiment. The third is cell measurement. A cell experiment is done in the same setup, lacking the reflective gold layer. As you can see in figure 4, they pick the typical microfluidic equipment used for measurement of cavity. The aurum mirror of the FP optical cavity are deposited on IR transparent substrate CaF2 and separate by micrometric polymer spacer. This figure is related to the experimental procedure. You can see in this figure, the FTIR spectroscopy is used to monitor the coupling. Once the appropriate coupling state on-off resonance is reached, the cavity-induced shift delta E VSC and the cavity and the ET30 polarity parameter can be determined by recording the absorption spectrum in the visible region and the CT band maximum position. This is the experimental procedure. First, we need to clean the solvent, and then an infrared spectrum is recorded. Then the similar cavity visible absorption spectrum is obtained, and we need to flush by nitrogen, and RD solution dissolved in the same solvent is injected, and another IR spectrum is recorded. The last is an absorption spectrum is recorded. By subtracting the neat solvent spectrum from the dye spectrum, the CT band absorption maximum can be determined. The similar procedure is carried out in a microfluidic cell that has the same path length but with the absence of the reflecting coat layer. And the observed alteration in the transition wavelength of RD delta lambda VSC is provided by this formula, by the spectral shift at the absorption maxima, and from which the difference of delta E VSC between the transition energy of the on-resonant cavities and cell experiment can be calculated by the second formula. First, this is the result and discussion. They learn the solution of RD in 1 nano by coupling the OH and CH stretching band simultaneously, which was unavoidable to their proximity and width. And how to confirm that the solvent was under VSC? The abyss splitting of the band were 350 feet and 195 centimeter power of -1, and were larger than the FWHM of the cavity mode, around 19 centimeter power of -1, and the vibrational band around 300. And they found that a 12.9 nanometer redshift of the CT band is visible region, and the appearance of inhomogeneous shifting is due to the smoothing conducted to the cavity spectrum to minimize the Fahry-Perot interference inherent to the optical cavities. And the experiment with off-resonant cavity were conducted to verify that the effect is caused by strong coupling, and the result was almost similar to that of cell experiment around 584, ensuring that the effect depends on cavity tuning and resonance. And we can see figure 7 is dependence of the VSC induced shift on the ET30 polarity parameter. You can see the color and shape mode. Blue circle is linear alcohol, green circle is terminal diol, red squares and is deuterated alcohol, and gray triangle is other alcohol. The deuteration only lowered the vibrational energy, but also introduce subtle modification to the molecular geometry and polarity. This is related to the Halevi et al. In 1958. You can see in this figure, this likely explain the phase transition like behavior observed in figure 8. Consequently, this implies that the localized state together and maybe their coherence could influence the properties of the solvent like polarity. Upon reaching the strong coupling threshold, the CT band of RD abruptly shift. And we can see in figure 9 that the dependence of the VSC induced shift on the solvent accessible surface area for C5 alcohol. In this figure, we can see the molecule surface area is reduced by branching, and strength of the dispersion force has also lowered. They therefore examine the delta E VSC in C5 alcohol with various connectivity. And delta E VSC increased proportionally to the surface area in the following order: cyclopentanol, isopentanol, 2-pentanol, and 1-pentanol. As you can see, in linear 1-pentanol has the highest surface area. The area decreased with benching 2-pentanol and isopentanol, and is the lowest for the cyclopentanol. Delta E is clearly proportional to the surface area, presenting that the dispersion interaction are altered under VSC. In order to further illustrate intermolecular interaction, they also plot the shift against additional variable, including viscosity and surface tension. As you can see in figure 10, a linear trend is found for linear alcohol, as you can see in the blue dot, blue point. A linear relationship is found between the surface tension of this compound and the change generated in this series of aliphatic alcohols as shown in this figure. There is a linear trend, you can see in blue dot, for alcohol, which lend credence to the idea that dispersion force change under VSC. And the conclusion of this paper is they investigated the effect of VSC on the polarity when alcoholic solvents are coupled, as indicated by Richard Dye solvatochromic response. Second is the majority of alcohol show the redshift in the visible range in the dye absorption spectra, which is indicative of effective decrease in polarity. The third is there was no shift was observed in short chain system like ethylene glycol or methanol. The fourth is prolonged aliphatic alcohol, a considerable shift if up to 50 nanometer is observed, indicating a change in solvent polarity. This spectral shift, the trends show that dispersion interaction are the main factor guiding the system behavior. And the last is modification in solvent properties need to be considered in studies of modified reactivity and other physical chemistry studies under VSC. And this is the reference based on this paper. Thank you.